I would like to welcome for the Keynote Session 1 title, Mechanical Behavior of Lime-Treated Soil Subjected to Varying Metal Sulfate Contamination by Dr. Arvind Kumar at IACESD 2023. I request Mrs. Deepthi to introduce the keynote speaker to the gathering.
Thank you, Soumya. I, Deepthi Das, Department of AIML, takes immense pleasure to introduce our keynote speaker, Dr. Arvind Kumar. Dr. Arvind Kumar is currently working as an assistant professor in the Department of Civil and Environmental Engineering at Indian Institute of Technology, Patna. He has completed his PhD from Indian Institute of Science, Bangalore, and MSc in Engineering from Fulcha Campus, Institute of Engineering, Nepal, in Geotechnical Engineering. His research interest includes in the area of soil stabilization, ground improvements, biogeotechnics, geo-environmental engineering, and rock mechanics. Dr. Jha has published more than 40 papers in various national and international peer-reviewed journals, books, chapters, conferences. He has awarded 2 doctoral students and is currently guiding 5 PhD students. Dr. Jha is also involved in many prestigious consultancy projects of governments of India, such as Smart Cities of Bihar, Nimami Gange, National Highways and Infrastructure Development Corporation Limited. He has over 10 years of professional experience, both in academia and industries in the field of geotechnical engineering. He has also received many prestigious awards by different organizations like International Society for Social Mechanics and Geotechnic Engineering, Nepal Academy and Science and Technology. Dr. Arvind is editorial board member of 8 international journals, including associate editor, Toxic and Radioactive Waste. He is a member of various professional bodies like member of Soil Improvement Committee, GI Institute, life member of Indian Geotechnical Society, Nepal Geotechnical Society, Indian Society of Earthquake Technology, International Society for Rock Mechanics and Rock Engineering. Dr. Jha has also chaired and co-chaired and delivered various keynotes, expert lectures on various national, international conference, seminars, FDP and workshops. It's a great honor to have you as one of the key speaker of the day. We look forward for your presentation, sir. Thank you all.
So thank you very much for giving this opportunity, particularly to JIT. So without wasting the time, I will start my presentation. Today I am going to start the presentation on the mechanical behavior of the lime-treated soil subjected to varying sulfate contaminant. As we know, for any kind of the infrastructure, we have to have good soil. Then only it will it will take the load, or it will distribute the load to the subsurface, and then your structure will be stable for any kind of the sustainable development. So my lecture will be, because we have the limited time, so I will go quickly. So I will discuss my presentation in 2 parts. First part I will discuss about little bit background, general theories and all those things, and second part I will discuss about how the contamination will affect the properties of the soil. So as we know, there are we have the problematic soil. Why it is called as the problematic soil? Because it creates problem to the structure when you construct the structure without knowing its characteristic or any kind of the without any behavior, then it will cause the failure to the structure. So we have different this classification has been done in 2 ways. One is chemically induced and other is the physically induced problematic soil. Because chemically induced, why it is chemically? Because it has certain chemicals which creates the problem changing upon the environmental condition. And similarly physically induced soil, that is the collapsible, liquefiable, and that is based on basically change in the moisture condition, or if the soil is sandy, or it creates the liquefaction once water table will high. So these are some of the problematic soil, and if you go without any treatment or any improvement, then it creates the problem to the structure. So basically I will be focusing about the expansive soil. As we know, if you are the civil engineering student, it is very common, because our India, whatever land is there, 20% is covered by the black cotton soil, which is known as the expansive soil. Why it is expansive? Because it contains the montmorillonite mineral basically. Okay, montmorillonite can absorb the high, like it has the high absorption of the water capacity, and it can it can accumulate. This is the clay particle. You can see the flat clay particle. This dry condition is once water will come into the picture, then it water can enter into the two plates and then it will expand. So it has a high highly expansive soil, and if you are going to construct any light structure and all those things, you can see this type of the swelling will cause, and then a structure will be damaged. So for that one, you have to stabilize this soil basically, and there are other phenomena, other factors that which can make this soil highly swelling. That is the surface area basically. If you talk about the different type of the minerals into the soil, because your clay soil have the different minerals basically, if you categorize it, that is the kyanite, montmorillonite and the halite. Basically 3 group of the soil minerals are there. So among them, this smectite group of the mineral, that is the montmorillonite, this is the swelling soil, and these other are non-swelling soil it goes, because you can see one of the factor of the swelling is the surface area, because you can see even though the particle size is less, but it has a higher surface area of 800 meter square per gram compared to other type. Means what does it means? If you take 1 gram of the montmorillonite clay, it will cover the whole football ground of the 800 square meter. So that is the a huge amount of the larger surface area it has. So that's why it can absorb the high amount of the water and then it will swell. So you can see the summary of these different clay minerals. Why I am talking about this, all those things, because you should understand about the what are the different factors that can affect the swelling phenomenon, and particularly with the montmorillonite and the vermiculite compared to other type of the non-swelling like the kyanite and the chloride. So you can see the cation exchange capacity, that is the ionic exchange capacity. Once the change in the environmental will occur, there are some kind of the contaminated water or contaminated chemical into the soil, this particular clay or the mineral will change the ions between these environmental factors or with the water. So you can see the cation exchange capacity is highly for the montmorillonite compared to other things, and I already told you about the specific surface area. That's why particularly you can see this swelling potential is high for this type of the minerals. So how to encounter this the problem of this swelling, or how to improve the behavior of this kind of the problematic soil? So generally we use the terminology. There are 3 terminology we used. One is the ground treatment, ground improvement and ground modification. Basically there are slightly difference in these terminology, that's why I kept here. Ground treatment is nothing but the process, which process you are going to use, either the chemical stabilization or the mechanical stabilization or any kind of the biogeotechnical stabilization. This is the process that you have to adopt, and then finally come to the ground improvement, that is the purpose of the process. Purpose of the process means which parameter that you want to improve. You cannot, for example, it's you want to construct the road. Which parameter is required? One is the subgrade strength. So your target should be to improve the strength. It's not like all parameter you can improve at the time. And the other is the ground modification and the stabilization. That is the result of the process. Once you apply, once you fix the treatment process, what result you will get? It's not like always you will get the good result. There will be the adverse effect also. So that you have to ensure before. So the classification, there are several classification of the ground modification. It's general things that you can find out in the many textbook. Okay, so mechanical, hydraulic, physical, and the inclusion of some of the confinement like geotextile, micropiles and all those things. And recently it is developed, that is the biological treatment of the soil, that using the bacteria, or soil has already contains, soil has its soil bacteria, how to feed some nutrient solution, and then by growing this bacteria into the soil by using some calcite solution, cementitious solution, you can stabilize the soil. This is the recent area in geotechnical engineering. So, or maybe you can use the combination of these. So in this presentation I will be focusing I'll discuss about the chemical modification, because it is widely adaptable, and this you can use for the both shallow and the deep foundation, deep soil stabilization. It is very cheap, because you can find cement, lime or whatever calcium based stabilizer everywhere in the world or any part of the country. So, but the one thing, major things when you are going to use for the chemical stabilization, these points are very important. It's not like blindly lime is okay and you can use for any type of the soil. No, it will create the problem. I will discuss later also. So, what are the things that you have to know prior to the implementation of this technique? First is the clear idea about the desired result. What result you are trying to get, that you have to fix either the strength parameter or the permeability behavior you want to improve, or you want to improve the volume change behavior. So, these parameter you have to, or this property you have to know, desired result you should understand. Other is the understanding of the type of the soil and their characteristic. Because you are going to stabilize the soil by using the chemical stabilization, so there will be the soil chemistry. It will react, chemical will react with the soil. Okay, and because soil contains different type of the minerals, montmorillonite, kaolinite, so it will react with the whatever additive you are going to use. So you should have the clear about idea about the what is the characteristic of the soil, what are the different mineral, what is the physiochemical behavior of the soil. Otherwise, reaction goes adverse as well. So then other is the understanding of the use of the additives, how they react, what are the different soil types, other additives, how they react with the surrounding environment. Because any structure we are going to build or construct, that is for the long term. So once you establish, it does not mean after 10 years or after 14 years or after 4 years, it will be same. Because environmental condition will be different. You have the freeze and thaw cycle, you have the wetting and drying, or any kind of the contaminant will occur into the ground. So whatever stabilizer you are going to use, that will give you the strength for the longer duration or not, that you have to ensure. Other is the understanding of the means of the incorporating the mixing of the additive, how you are going to mix, that is very important, and understanding of the how the result engineered soil will perform, that is the longevity potential of the soil. After long term, how your stabilized soil will be. So these are the parameters that you have to ensure in the beginning itself before going to use the any kind of the chemical stabilization. So why I am saying characterization of the soil is very important, because I'll tell you some strong basis, because your soil sample, as if you are civil engineering student, you know your soil is three-phase system. Basically it contains the solid and water and the voids. Voids may be air and other generally air. So solid. So when you are talking about the solids, you can see if your soil contains the clay, if your soil contains sand or the silt, there is no reaction with the any chemical phenomenon, or slightly we are giving we are talking the sand is good compared to the clay. But if you have the clay into the soil, because clay contains different type of the minerals, there are thousands of the soil minerals into the soil. It's very difficult to handle the clay compared to the sand, because sand contains only quartz or the silt. That's all. Okay. So even though up to find like you can characterize the soil, or you can say if suppose your clay contains smectite group of the minerals like montmorillonite or the mica or the kaolinite, that's fine. But what will happen if there will be the presence of the water? If montmorillonite is there, it will swell. Now you can see the consequence. Once generally in the laboratory, what you are using, the still water, it is the fresh water, there will be no contamination. But in the ground, there will be the contamination of the water. So in that case, now see what is the complexity in understanding the chemistry behind reaction of the contaminated water with the clay. So that's why dealing with the clay is very difficult compared to the sand. And you can understand the consequences, what will happen, because all are the soil chemistry related things. So whatever the reaction product will be there, it will be favorable for you also, and it will be favorable for the structure, or it goes adverse also. So that understanding is very much required. So that's why characterization of the soil is very important. So another thing why I will tell you one example here over here. You know the consolidation. Basically consolidation will give you the idea about the how much settlement is there once you apply the load onto the ground. So this is the CV parameter. This is called as the coefficient of the consolidation, which is the one of the characteristic of the compressibility. So you can see here this graph is very interesting, which is this Robinson and Alam in IISc Bangalore has this research on this area. So you can see there are montmorillonite, elite and the kyanite. Even in the montmorillonite there are different type of the montmorillonite depending upon the cations, either your interlayer regime, either it is sodium or the potassium or the magnesium. So their behavior will change. So that's what in this graph it is very interesting. So here you can see the sodium montmorillonite, here this is the calcium montmorillonite. You can see the compressibility behavior. This curve is for the calcium montmorillonite, this is for the sodium montmorillonite. Both are montmorillonite but their cations are different. So due to that you can see the change in the coefficient of the consolidation. So that's why it is very important to understand about the soil mineralogy. So there are in environment you can find lot of interaction phenomenon, like you have the temperature, you have the pH, you have the liquid phase, gas phase, and all interact with the clay. So now you can see that leads to the intricate engineering problem or behavior, especially you are dealing with the fine grained soil. So now coming to the, I will just go quickly with the mechanism of the improvement in the behavior of the soil when you are going to use lime. So lime, you know, it's very commonly available, and it it is, you can find in the 3 types: calcium oxide, calcium hydroxide and the calcium carbonate, and it has a cycle depending upon the temperature and pressure, it will change its characteristic. So there are several applications of the lime stabilization. You can find there is the application in the road, railway, this airport, house, this stabilization of the subgrade soil or the embankment, and you can see how this lime, because it is well known phenomena. You can find National Lime Association has already developed one protocol how to use the lime or how it strengthen the soil. So there are mechanisms, basically 2 mechanisms. One is the short-term reaction and other is the long-term reaction. Short-term reaction basically it their cation exchange and the flocculation. Basically short-term reaction means once you add the lime into the soil and if you add the water, then it will start reacting. And that reaction quickly it will happen, cation exchange will happen, because your clay, the soil contains the alumina or the silica or the sodium or the potassium, and lime contains the calcium, that is the divalent ion. So monovalent ion will be replaced by the divalent ion, and that causes the change in the fabric of the soil. Initially your soil is dispersed, then once this flocculation will occur, this soil will be arranged like that. Okay, so that basically causes the change in the physical modification of the soil, like plasticity characteristic or the consistency limit. That is called as the soil modification. So short-term reaction is basically responsible for the modification of the soil or change in the physical characteristic of the soil. Another is the carbonation is this list effect, and it will affect once if the area is highly it's a hot area or the temperature of the area is very high, then this phenomena will affect, otherwise it will affect minor. So long term reaction is basically pozzolanic reaction. By the name itself you can see it will take some time. So that's why you are if you are civil engineer, you are curing the sample for 28 hours. Okay, 28 day. So that's why you are curing for 28 day, because it will take some time to react and to form some of the cementitious compound. So long-term reaction, pozzolanic reaction, is basically dissolution of the silica and the alumina, because soil contains silica and the alumina, and that react with the lime. Lime will give you the high alkaline environment because lime pH is 12.4. So then in that environment, there will be the formation of the cementitious compound like calcium silicate aluminate or calcium aluminate silicate. So that will cause the binding agent between the soil particle, and it will it will compact, it will increase the density of the soil and it will increase the compactness of the soil, and then the strength will improve. So there are several factors of the lime soil stabilization. I will not go into the detail of that one. So we have done this work by taking the soil from the Karnataka itself, Belgaum district, where you can find the black cotton soil, and this characterization, we have done detailed characterization to understand about the mineralogy of the soil, and we have done some of the X-ray diffraction analysis and this SEM and the EDAX, like chemical composition analysis, and you can find this alumina and the silica ratio is approximately 1:2. So montmorillonite is called as the 1:2 mineral, because why 1 is alumina, 2 is the silica. So that we understood from here that our soil contains the monomer, so it is the expansive soil. So similarly, we have done the thermal analysis to understand how much inorganic or the organic contaminants are there into the soil. So this is useful for the to identify by using the thermal analysis. Then how to take the appropriate amount of the lime. So that is called as the optimum lime content. Optimum lime content will give you the maximum achievement into the strength. So that you can find out by the two methods. One is the pH method, that is the simple method, and other is the by performing the unconfined compression strength test into the laboratory. That is the little bit, it will take time. So quick method is the pH method. Once you take the pH of the different soil lime mixture, and whatever value at what lime content you will get the higher value, that will be your optimum lime content. So we found at the 6% is the optimum lime content for this particular type of the soil. It may vary depending upon the type of the soil. And then you can see the result of the strength behavior. We have tested the sample for the up to the 1 year to see the long term effect of that particular addition of the lime into the soil. And then you can see this is without lime, and this is after 1 year. You can see there is the increase in the strength is from 200 kPa to 1600 kPa. That is approximately 8 times increase in the strength of the soil. But to get this maximum achievement, we have to add the 6% lime. That is for the strength. Now the same thing, if you see the maximum swell, because your soil is expansive soil, to decrease the swelling you are adding the lime. But to eliminate the swelling, you required only 2 to 3% of the lime. So depending upon that, which property you want to improve, depending upon that you have to choose you have to take the amount of the additives. Okay. So then detail finding the mechanism, we have gone through the several micro analysis, and then we are able to find that there is the increase in the calcium and the silica ratio, decrease in the alumina and the calcium ratio, that causes that reflects that there are the formation of the cementitious compound into the soil, that is the silicate hydrate and the aluminate hydrate. So you can see in the SCM image, basically a scanning electron microscope. So with the increase in the lime and the curing period, how the bonding of the soil is increasing. This is particularly for the lesser amount of the lime, there is no bonding, and once you add the optimum lime content, you can see the compacted structure. And with the curing, with the increase in the curing, you can see the hard, this you can find the compacted soil. So same thing, this thermal analysis has been done, and then we can find we are able to get the idea about how much quantity of the cementitious compound is formed, and that you can see the same soil. This is for the 0 day, and this is after the 1 year. You can see the decrease in the weight loss, that whatever weight loss is there, that is nothing but the formed cementitious compound. So that you can exactly capture from the thermal analysis. So part B, basically I will go quickly. If lime stabilization, okay, it will give you the higher strength, it will give you the eliminate the soil, but does it same for the all environmental condition? Once the ground will contaminate, what is the effect of the what is the validity of the lime treatment? So that I will discuss here. So basically there are several contamination into the soil, either by the sulphate or the acid or the alkaline. Alkaline water will migrate into the ground, it creates the problem. So there it has been seen in the US or other part of the world, you can see lime stabilization has been done nicely, road has been built up, and after some time or after some year, there are the huge excessive swelling has been occurred into the soil, and all structure is failed. So why it is, so that questioning the validity of the lime stabilization or the calcium based stabilization. So what is the sulphate bearing soil? Basically sulphate bearing soil is the soil which contains the sulphate, and 20% of the land is covered with the sulphate. Different form of the sulphates are there. So you can see there may be the two condition of the sulphate bearing soil. One is in situ sulphate bearing soil, it is already present into the soil in the natural form, and other is the contaminated by the soil, because we are going to use different kind of the waste, or for the agriculture purpose we are using the gypsum or whatever, or waste plaster board. So that also contaminate the soil, and it migrate the sulphate into the soil. So other is the mining sources. You have in India there are different mining sources, and it discharges the different type of the contaminated water, and due to the pyrite oxidation there is the formation of the gypsum as well into the ground. So generally if you go to the mining area like the the Jharkhand or the Odisha, you can see there is highly problem of the vegetation, and that may be due to this contaminated water. So the gypsous soil is mostly common into the soil. Gypsum is mostly abundantly available compared to the other type of the mineral, because gypsum has the low solubility rate compared to other type of the minerals. So gypsum again, it has the unpredictable behavior upon, because in many literature you can find it is suitable for the stabilize the soil or unsuitable for this improve the behavior of the soil. So it has the unpredictable behavior because the nature or the form of the gypsum will be going to change upon the temperature. So if you see here hydration hydration of the anhydride to the gypsum is 30% swelling will occur, and if water will remove, then there will be the compression. So that causes the creates the problem to the structure. So there are many works has been reported which causes the damage to the structure. So that we have done some research work for the how the gypsum behaves into the soil. So you can see in terms of the strength, gypsum is 1-2% gypsum is giving good results, but again the same thing, the swelling, the same amount of the gypsum is giving the high swelling behavior. So it's very interesting, same amount of gypsum is for the strength purpose it is good, but the same gypsum for the swelling behavior or the volume it creates the problem. So that's why desired result is very much important. Which parameter you want to improve? So that is very important. So then obviously to find out the mechanism you have to go for the different micro characteristic. If you are interested, then I am just referring my paper which is already published for this work. You can read it. And so now I will come to the last part, calcium based stabilization on the sulfate bearing soil. So there are, you can see the effect of the calcium on the calcium based stabilization. So if you have the expansive soil and you have done lime treatment, two cases will be there. Then sulfate contamination will occur after some year or some time. Then what will happen? That is, there will be the excessive heave into the soil. That is called as the sulfate induced heave. That is the one case. Other is the if you have already sulfate into the soil and then you go for the lime treatment, then again it will create the problem. So two cases will be there. So and why it is why heave will occur? Because there will be the formation of the intrinsic minerals, that is highly expansive mineral. It can swell up to 137%. So how this intrinsic mineral form? There will be the calcium liberation of the calcium from the lime. Alumina will be there into the clay, and OH you will get from the water, and then it will react at the higher alkaline environment in the contact with the sulfate SO4. It forms the intrinsic. So this is the complex chemical reaction to form this. You can find in 1-2 page of this reaction. I will write this reaction. So intrinsic is, you can see this needle-like structure. If you see the microstructure of the needle, you can see this needle-like structure it will form. That is called as the intrinsic, and that causes the damage into the structure. So this, I will not go into all the detail, this chemistry and all those things maybe it's very difficult to understand, or you can go through my papers. Okay. So now you can see we have done some of the experiment to see how much swelling it will cause into the once you have done lime stabilization. But if sulfate is there, what is the adverse effect will be there? So you can see the swelling is you can see within 1 hour of the reaction, within the 1 hour of the preparation of the sample, you can see excessive swelling will occur into the soil. So if you have the 20 mm of the sample, you have the 20 mm of the sample, it swelling will occur within 100 hours. 6% of the swelling will occur if you have the amount of the gypsum is 6. So obviously the percentage of the swelling will vary depending upon the amount of the contaminant. So you can see the formation of the intrinsic. This is the complex, the flower-like or the bush-like that will form within your soil, within the voids. You can clearly capture from the scanning electron microscope how much quantity or for which type of the this sample, how much intrinsic will form, so that you can explain the mechanism. So now we come up with the hypothesis, or we have given some mechanism how it is swelling depending upon the cured sample and the uncured sample. If you have done the sample for the curing and then you go for the testing or to find out the swelling behavior, you will get less swell or minimal swell you will get, because during the curing process your soil is like bonded by the cementitious compound, and there it's very difficult to migrate the water into the pores. So once water is not there into the soil, there will be no reaction, there will be no the formation of the intrinsic minerals within the pore. So that's why in the cured sample you will see the increase in the curing time. There will be the bonding, this black color you can see the coating is the nothing but the cementitious compound, and this within the pore you can find this is the intrinsic minerals. But uncured sample, the long term reaction will not occur, cementitious compound will not form. So n number of the water molecule can enter, and then the formation or the growth of the intrinsic will fill, and then it will separate the soil particle. Separation of the soil particle means it will exert the pressure that causes the swelling into the soil, and you can see it is already published, and you can find this one into the literature. So the metal sulfate, till now we have discussed about the calcium sulfate. So there are different form of the sulfate. So maybe the calcium or the sodium sulfate, magnesium sulfate. Why it is called as the metal sulfate? Because if you have the gypsum, not only the sulfate ion is there, but calcium ion is also there, and the same calcium ion is giving good result for the lime treatment. Understand the things. Okay, but if you have the sulfate, other metal sulfate like the sodium, magnesium and the potassium, it has the other type of the cations like the sodium, magnesium and the potassium. So both have the divalent and the monovalent cations. So it behaves or it reacts with the soil differently, and that's why the consequences of the change in the behavior of the soil will be different. So, we have done our students have done some of the experiment. You can see the plasticity index with the metal sulfate. Plasticity index in the simple language, if you understand, if you have the sand, there is no cohesion or stickiness into the soil. If you have the clay, there will be the cohesion into the soil. So plasticity index will indicates the cohesiveness into the soil. So if you have the lime treated soil with different metal sulfate, the sodium sulfate is giving the increasing basically the higher plasticity index at only 2% metal sulfates compared to other type of the minerals. So then we have go through the maximum swelling percentage, and then you can see depending upon the type of the metal sulfate, the percentage of the swelling is different. So this is basically 0 means what? There is no metal sulfate, only lime treated soil. There is no swelling into the soil. Once sulfate is introduced or different kind of the metal sulfate introduced, you can see the excessive swelling into the soil. That means lime treatment is not effective for all type of the soil. You can understand. If contaminated soil is there, you have to first characterize the soil. You have to see the consequences. Then only you apply the lime treatment of the soil. So you can explain the mechanism by performing different kind of the microstructure. I will not go. Then we thought how to minimize this, the effect of the sulfate. Then we go for the mellowing period, because let it be grow. Mellowing period is nothing but putting all the chemical, mixing the soil and leave it for the some period. So before compacting the soil, that is called as the mellowing period. So let it be grow. Intrinsic mineral will grow, it will grow. So we have mixed the soil, kept for the some period 2-3 days, 4 days, and obviously intrinsic mineral will grow, and then after that we have compacted the soil, and then we have tested it. So that's we try to decrease the effect of the sulfate. So you can see there are this result is, although you can see this is the 0-day mellowing period, this is the 1 day, and this is the 4-day mellowing period. We can see there is the decrease in the swelling behavior of the soil, decrease in the swelling, but in the same time if you see the strength behavior, it is decreasing with the mellowing period. Why it is so? Because you can see intrinsic will form into the natural condition, and it has the less effect on the swelling, but in the same time during the mellowing period, cementitious compound or the modification will also occur into the soil. That is not suitable, because once you compact the soil, then only there will be the binding. In the loose soil there will be no binding. So that's why the swelling is decreasing, but strength is also decreasing continuously. So then we go to the wetting drying cycle, because in the environment you have the sometime it is rainy season, sometime water content is different, soil moisture is different. So it also affects the behavior of the soil. So we have tested the sample, keeping the sample for the different cycle of the this wetting drying cycle, 1, 2, 3, 4. Like one cycle is equivalent to 24 hours for the wetting and 24 hours for the drying. So how deterioration of this behavior will occur into the soil? So you can see in all case we have found that the decrease in the strength with the increase in the wetting and drying cycle. So yes, summary, I will conclude here by saying that yes, lime or chemical stabilization is effective, but you have to thoroughly check, like doctor is diagnosis, no, first by prescribing the medicine, he has to understand about all the test report. So that's why similarly as a civil engineer or geotechnical engineer, you should know the behavior or the characteristic of the soil first, and then you apply the medicine like the chemical stabilization or other type of medicine. Then only it will help. Otherwise, it will create the problem, and whatever the goal of the sustainable development is there, it will not achieve. So that you should understand. Yes, now I will just invite you to visit IIT Patna, because we have the nice campus in the bank of the Ganga River, and we are going to organize one conference, international conference on January. And this is geotechnical issues in engineering, infrastructure and disaster management. So abstract submission deadline is still there, July 31st, up to July 31st. You can submit the abstract, and you can visit many ancient places, Nalanda, Rajgir, Gaya, which is nearby to our the campus. So you can visit many ancient places, because it is very difficult to go frequently from South India to North India. So this is the best way to connect with the people. We can see the places. Using some microorganisms to stabilize the different problems in the geotechnical behavior. We have the computational facility, and these are some of the research we are currently my teams are working on this one. This is biogeotechnical to stabilize the slope or the soil erosion and all those things. So if you are interested, obviously you can mail me, and you can connect with the IIT Patna. You are always welcome as the students. You come for the internship or any kind of the project. So that's all. If any questions are there, I'll be happy to answer. Thank you very much.
Was 50 kilometer, 200 kilometer project we are executing. So they are actually in a specification, it is written that based on UCS, we have to conduct one UCS test and conclude that it is okay or not. So this whatever calcium and gypsum impact is there, that details are not there in even a specification.
Correct.
So we are using there for somewhere.
Yes.
That will fail or that will pass. So how to implement at site these things, that we have to think. And
Yes.
And the major thing is there. So suppose 50 kilometer we have. When we are going to do excavation for 100 meter, 200 meter here or somewhere, then we are getting clay soil. So if we are getting clay soil, then we have to do this much analysis. That much facilities are not there, and people are not aware about these analysis. First thing. Second thing, mixing, how to do mixing. Suppose these clay lumps are there, some moisture is there, first we have to dry, then if we use pulverizer and this lime spreader, then it can be effective. Otherwise we are doing something horror and some method we are using, so it will not mix with this soil grain size.
Correct.
So if it will not mix with surface area, then it will not be effective.
Yeah,
we are testing some in laboratory, we are testing some this UCS and we are getting. But at site it is not. So challenge is how, if it is 50 kilometer, then one contractor can bring that spreader machine or pulverizer. But somewhere 500 meter, again somewhere. So it is not being implemented properly, though it is in a specification of ministry. And how it can be adopted at site. So means plenty of soil we are removing from road and getting from. So this is affecting our sustainability of environment. So it is major part we have to think how we have to implement at site actually. So knowledge wise, first thing knowledge wise, and second thing this is again it is taking time also. So we have to complete this road work within 2 years. So if we taking this much time for analysis and again for curing period, for consolidation, then it is means it is not going to be complete within that period. So it is a great challenge being in our whole means society. I am asking. So we have to raise this issue,
Yes,
and
yes.
we have to think about that. Research is there on paper, it is there, but it is not being implemented at site. So we are not getting benefited.
Yeah, so we should modify our this whatever the codal provision is there, because right now we don't have the codal provision, particularly in Indian standard. We don't have particularly codal provision for the chemical stabilization or other types. We are using some conventional coding things. Okay, so but the anyway you have to whatever like no you are going to method or improvement method you are going to implement into the site. First job is to do laboratory test. So that's why laboratory test is, because it's not like only the for the knowledge purpose or whatever. Same thing, whatever in the field condition is there, we are trying to replicate the individual laboratory in the smaller scale. That's what. And the same thing we are trying to implement in the laboratory again. So that is the like laboratory experiment is always better, always good.
Yeah.
Otherwise, you cannot blindly go and simply compact the soil or simply use the any kind of the method. So laboratory testing, like suppose I am using lime or whatever. So this or soil, this all are replicating the field condition. Obviously, sir, you are true, because we have to modify our like no codal provision, and we have in practice also we have to adopt all those things. Then only like no it will be good. So yes, more like no discussion is required or in this.
Yeah, yeah. In this means both the things, how to
Yeah,
implement and
Correct,
analysis,
correct,
both
correct.
the things.
Yeah.
We need. This
Yeah.
is the big challenge actually.
Yes.
For our sustainable development.
Yeah.
Okay, thank you.
Thank you.
Right. Thank you very much. My name is Engineer Duri. My background, I'm very much impressed by the presentation.
Thanks.
I'm very much impressed. I'm coming from a background where I am also a material scientist, material technologist.
Yes.
And I'm also coming from a background where I've produced patents in geopolymer cements.
Correct.
Yes, I've done those with Amit International University, which is an Indian institute where I'm doing my doctorate. Interestingly, when you were doing the presentations, gypsum, calcium, potassium, the world in terms of cement manufacturing, in terms of soil stabilization, is now moving to use one of the products that we have highlighted there, kaolinites. Kaolin, metakaolin, MK750, MK850, that's a stable compound. I'm sure you have alluded in your report. So what has been happening as of late is that so far, geopolymer cements, which is the same cement that has been used historically by our old great-grandparents to manufacture the historical items that were showing us for us to visit. Yes, the Egyptian pyramids. They used the kaolinites to make geopolymer cement. It is sulfate resistant, it is chloride resistant, so it's very stable. So we are now going to the next step of popularizing the elimination of calcium and the use of aluminosilicate. Was in the geopolymer cement we are looking using an aluminosilicate bonding, which is very stable. So as civil engineers, we now need to start getting into that. So what I've done with Dr. Naveen, BP in Amity, is I've just developed a cement manufacturing system for mass production of these geopolymer cements. Right now, it's only being done for small scale. So we now have a patent for the large scale manufacturing of geopolymer cements. That is what I see as the solution to stabilize, for road stabilization.
Yes, correct.
Yes. So this is where we are going now. I was supposed to present one of my papers here, but there were a few issues, but it had already been accepted. So I was going to share more light on that also. But a number of processes are actually involved. I'm happy to say we are all in agreement. Kaolinite is the way to go. Elimination of calcium hydroxide in the equation, which also unfortunately is going to make a lot of resistance from manufacturers of cement, because most cement plants were based on availability of calcium. In this particular case, you just need clay, which is kaolinite, and it's abundant everywhere. So it can now start to be produced on a small scale by small players. So this is the way that we are now progressing towards. Thank you very much for your presentation.
Thank you. We'll talk during the lunch maybe in detail. Yeah. So because other keynote speaker is waiting, so we are sitting behind the time, and yeah. Thank you very much. Yeah. If you have any question, we can meet during the lunch. Yeah.
Thank you, Dr. Arvind Kumar Jha, sir, for sparing the time and sharing your key message among us. Now I request Dr. Srivalsa sir and BVV sir and Satyanarayan sir to come and facilitate